Good morning friends, welcome back to Parnika tutorials. In this video, I want to discuss various operators in Java. Java supports 8 different types of operators such as arithmetic operators, unary operators, relational operators, logical operators, bitwise operators, ternary operators, instance of operator, assignment operator. All these 8 different types of operators I will discuss in detail with you. So I sincerely request everyone to watch the complete video for better understanding. First, let me discuss what is an operator. Operator is useful for you to perform the operation. Suppose, let's take that x plus y. This plus is the operator and x and y are the operands. Plus is the operator. So here plus will perform the addition between the x and y. So the plus we will call it as a binary operator because it needs minimum 2 operands. But whereas the post increment, the post increment is a unary operator because you need only one operand. Similarly, we'll discuss about the ternary operator. It needs 3 operands. Based on the number of operands required, then accordingly we will call that as a binary operator or a unary operator or a ternary operator. Now let me discuss about the arithmetic operators. Java supports addition, subtraction, multiplication, division and modulus. These are the 5 arithmetic operators Java supports. Now let me discuss with a simple example. Let's take that a value, I am taking it as 6 and b is equal to 2. If I perform a plus b, then 6 plus 2, meaning is that whatever the value which is there in the variable a and the value which is there in the variable b will be performed addition. So, which is 6 plus 2 will be equal to 8. Similarly, if I perform a minus b, meaning is that the value which is there in the variable a minus the value which is there in the variable b will be 6 minus 2 is equal to 4. Similarly, if I perform a into b, which will be 6 into 2 will be 12. If I perform a division b, which will be 6 division 2, the division will give you the quotient. 6 by 2 will be equal to 3. Similarly, if I perform a modulus b, then it will perform 6 modulus 2. The modulus operator will give you the remainder. The remainder will be 0. How? Because 2, if you divide by 6, 2 3 is a 6, so a remainder will be 0. So modulus operator will give you the remainder and the division operator will give you the quotient. So this is about arithmetic operators. Now let me discuss the arithmetic operators with a simple program. I will use the class and the class name. So I will take the class name as operators. And you know that the O should be capital. And then I will write public static void main string. I will write S capital string. I can write args or anything, I can write it. It's not a problem. It should be an array. So here S should be capital, here O should be capital. And then I will write, let's take that byte, A is equal to 6, a byte, B is equal to some 2. Then I will write system, S should be capital. System dot out dot println. I can write like this. The sum is then I can keep a plus for the concatenation and I can write a plus b. This will give you the sum is 6 plus 2 output as 8. It will perform the a plus b. The a plus b is 6 plus 2, which will be 8. That will be concatenated to this string called the sum is. Similarly, if you want to perform the subtractions, you can write the same way. System dot out dot print ln. Okay, the difference is, let me write in shortcut, dif is, okay, then you can write plus, then a minus b. Is it clear? This will give you the difference will be 4. Similarly, if you want to perform the multiplication, you can write system dot out dot print ln. Okay, the multiplication is, let me write it as mul. Okay, then a into b. If you want to perform the division, same way, you can write the system dot out dot print ln. Okay, the division is, or the quotient is, you can write anything. The division is, okay, a division b. Similarly, if you want to get the remainder, okay, you can write system dot out dot print ln. The remainder is, or the modulus is, a modulus b. This one, you close this one and you close the class, and then you can compile this program. What is the way you can compile? You can write the command as javac operators.java, because whatever the class name you have kept, that should be the file name. Okay, once you successfully compile that program, you will get a .class file. Okay, to run that one, you will write a command called java operators. So now let me execute this program and show the output for you. I have created one folder called Java programs on the desktop. Let me double click on it. Currently we don't have any files in it. What I will do is that I will create a new notepad file, okay, and save it as, okay, I will save it as operators.java, okay, .java. Save it. Okay, now you can see there is a notepad file called operators. Okay, now right click it, edit with notepad plus plus. So the notepad plus plus we will use to write all the programs. Now class, okay, operators, you know that whatever the class name you have given should be equal to the file name whatever you have mentioned earlier. Okay, then public static void main, then I will write string where s should be capital, args, okay, and then I am opening the main function. Here what I will do is that I will declare two variables, byte a is equal to 4 and b is equal to 6. Okay, now I will write system dot out dot print ln, okay, where s should be capital. Okay, the sum is, I will write this one, and you can write whatever you want to write here, and then you have to use the plus for concatenation, and I want to perform arithmetic addition between a and b. Okay, so I am doing a plus b. Similarly, I will copy the same thing and paste here to perform the subtraction, all these things. Okay, I want to perform the subtraction, multiplication, division, and then modulus. So I will write here the difference is, I will use a minus b, and the multiplication is, I will simply write mul, multiplication is, for the quotient or the division is, okay, it will give you the quotient. The remainder is, or the modulus, okay, modulus is a modulus b, oh sorry, a modulus b. I will close the main function and I will close the class. Okay, we have successfully written the program. Let me guess what will be the output in each scenario. A value is 4 and b value is 6. So a plus b, it will produce the output as 10. And then here a minus b, 4 minus 6, it will produce the output as minus 2. A into b, 4 into 6 is 24, and here it will produce the 0. Okay, and here the quotient will be quotient is 0 and remainder is 4, because 4 by 6 the quotient will be 0 but remainder will be 4. Is it clear? Let me save this one and then execute it. How can I do it? I will open the command prompt. First I will go to the desktop, cd desktop, and I need to go to the Java program. So I will write change directory cd Java programs. Is it clear? Now I will type a command called javac file name operators dot java. Look at here, it was successfully compiled. Now to run it, I need to write Java file name, okay, operators. Look at here, we are getting an output as the sum is 10, the difference is -2, the multiplication is 24, the division is 0, the modulus is 4. I hope it is clear for you. Now let me discuss about unary operators. Java supports various unary operators such as unary minus, okay, and then increment, okay, this will be a unary minus, okay, and this will be increment. In increment you will have a post increment and also pre increment. Similarly you will have the decrement, you will have post decrement and pre decrement. So now let's take that I have minus a, this will be your unary minus, and if I write x plus 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 x, okay, x minus 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 x, so these are the unary operators. So this is your post increment, this is pre increment, this is post decrement, this is pre decrement. Now if you look at how many operands are there, in this case only one operand. In both these cases only one operand is there. In these cases also you will have only one operand. So that's why these operators we will call it as unary operators. Similarly you have the logical NOT operator also, which is also one of the unary operator, but I will discuss about the logical NOT operator while discussing about the logical operators. Like you will have logical AND, logical OR, logical NOT. There I will discuss about this one. Now the unary operator, suppose let's take that you have the a value is equal to 6. If you write minus a, means where minus is the unary minus, then it will display the output as -6. So this is about the unary minus operator. Okay, now coming to the post increment, I will discuss with a simple example. Let's take that you have byte is a variable, byte is a data type, okay, and x is equal to 4, where x is the variable and byte is the data type, and you know that byte will occupy 1 byte, okay. Now if I write system.out.println, let me write system.out.println. If I am writing, let me write here dot println, okay. If I write x plus plus, lot of students will do the mistake stating that it will give you the output as 5, but however it will not give the output as 5. This will give you the output as 4 only, okay. So as it is a post increment, okay, first you will assign the value, then you will increment. Again if you write system.out.println x, in this case it will give you the output as 5 because already the increment has been happened. Now let me discuss with one good example, okay, the post increment and pre increment. Let me take the standard one, m value is equal to 5, and if you have written a statement called y is equal to m plus plus, okay, then look at here how many operators are there? One is assignment operator, and then you have the post increment. So it is a post increment. So the meaning is that here the increment you need to give the least priority as compared to the assignment. So first you will write y is equal to m. Now what is the m value? 5. So y will get the value as 5. Then you will increment the m value. So it will be m is equal to m plus 1. Already m value is 5. So 5 plus 1 it will be 6. So if you print the y value and m value, you will get the output as 5 and 6. So the post increment, first it will do the assignment and then it will increment it. Okay. Similarly, if I take the same example with the pre-increment, okay, then first it will increment. You have the assignment and increment. As it is a pre-increment, the priority will be given first for the increment, then assignment. So in this case, first you will perform m is equal to m plus 1. What is the m value? 5. 5 plus 1 will be 6. So m will get the value as 6. That value you will assign to the y, because next is the assignment. Y is equal to m. What is the m value? 6. So y will get the value as 6. I hope you have understood about the post increment and the pre increment. Similarly, the post decrement and pre decrement. If it is a decrement, first you will do the assignment. Post decrement means first you will assign, then decrementation will done. Similarly, if it is a pre-decrement, first decrement will happen, then assignment will happen. So I hope you have understood about the unary operators. Now let me discuss these unary operators with a simple Java program. Let me take a class, okay, and the class name is operators, okay, where the O should be capital, okay. Then I will write public, okay, static void main, okay. Then I will write string where s should be capital, okay. String, you can write args or any array you can take, okay. Then you open this one and then you can define some variable, okay. Byte, okay, x is equal to 4. Then if you write system dot out dot print ln the unary minus, okay, the unary minus, you can write like this. Plus is for the concatenation, then you can write minus of x, okay. Is it clear? This will give you the output as minus 4, okay. This minus is your unary minus and this plus is for the concatenation. Similarly, if you write system dot, okay, out dot print ln the post increment, okay, I will write shortcut inc, okay. I will perform the concatenation and I will write here as x plus plus, okay. Similarly, here I will write system dot out dot, okay, print ln, okay, and then I will write the pre-increment, okay. I will write concatenation and then I will write plus plus x, okay. Then I will write system dot out dot print ln, okay. The post decrement is I will write x minus minus. Similarly, I will write system dot out dot print ln the pre-decrement is you can write minus minus x, okay. Then let me close the public static void main and then I will close the class, okay. Now look at here, what will be the output in all these 5 scenarios. As byte x is equal to 4 and you have written minus of x, then in this case, okay, it will give you the output as minus 4. Is it clear? It will give you the minus of x, it will become minus 4, okay. Are you able to understand? Is it clear? Now let's take that you are done this one and you have erased this part, okay. Now look at here, the post increment is x value is how much? 4, okay. Now you have written 4 plus plus, then what will be the output? Lot of people will think that it will give the output as 5, okay, but however it will give the output as 4. Already I have discussed this scenario, like as it is a post increment, first it will do the assignment. Okay, it will do the assignment. So what is the x value is there, 4 is there, that will be displayed as an output. Now once it assigned, then x value will be incremented, so it will be x is equal to x plus 1. Now x value is 5. Are you able to understand? After assignment it will increment because there is a post increment. Okay, so now x value is 5, not 4. Remember this one. Now look at here, system.out.println, the pre-increment is, so the pre-increment means first you need to do the increment, then assignment. Already x value is 5, so if you again perform x is equal to x plus 1, which is 5 plus 1, now x value will be updated to 6. That 6 will be assigned. So in this scenario, you will get the output as 6. Are you able to understand? I hope you are getting the point. Okay, the post increment means first it will assign. So that's why x value is 4, that value will be assigned. So you will get the output as the post increment is 4. After assigning, it will increment. So x is equal to x plus 1, 4 plus 1 is updated to 5. Then when you are executing the pre-increment, first it will do the increment, x is equal to x plus 1, 5 plus 1, 6. That value will be assigned. So now the x value is 6, 6 value will be assigned. So that's why you will get the output as 6 in this scenario. System.out.println, the post decrement. Now what is the updated value of x? 6. As it is a post decrement, first you need to assign the value. So in this case, you will get the output as 6. Okay, then it will perform the decrement, which is x is equal to x minus 1. 6 minus 1 will become 5. Now look at the last statement, system.out.println, the pre-decrement is, so first it will do the decrement. So already x value is 5, again 5 minus 1, it will be updated to 4. That will be assigned here. So the pre-decrement, you will get the output as 4. So this program will give you the output as minus 4, 4, 6, 6, 4. I hope you have understood. If you want to compile this program, you need to write a statement called javac operators.java. Then you will get a class file. Then you need to execute with the help of command called java operators. Now let me execute this program and show the output for you.
Now let me perform the unary operation. So I will write a program to perform the unary operation. So I will keep all these things like class name and public static void main, all these things. Now I will write few lines extra. I will write system dot out dot println, and then I will write the unary minus. The unary minus is, I will perform the concatenation. Here I will use unary minus and then I will write a. Similarly, I will write system.out.println, the post increment. The post increment is, the post increment on a is, I'll simply write something. Okay. Then I will use plus for concatenation. Then here I will write post increment. It will be a plus plus. Similarly, I will do the post increment, means pre-increment, pre-decrement and post-decrement. All these things we will discuss. We are done with the post-increment. Now I'll do the pre-increment. Here in place of a plus plus, I will write it as plus plus a. Then post-decrement I will do. Post decrement I will do on a, it will be a minus minus, and this will be pre-decrement. Pre-decrement, it will be minus minus a. Now let me execute the program. Before executing and show the output for you, let me guess what will be the output in these scenarios. As a value is 4, unary minus of a will produce the output as minus 4 for you. And the next one, a value is 4. As it is a post increment, first it will assign the value. A value is how much? 4. That value will be displayed. So here also you will get 4. Now look at here. This is pre-increment. Already on A, see, after assigning A value will be incremented. Now A value is updated to 5. On this one, you are performing the pre-increment. So first you will increment the value by 1. Now the A value will be updated to 6. That value will be displayed. So here it will give you the output as 6 for you. Now A minus minus. So first whatever the A value is there. What is the A value is there? 6. That will be assigned and that will be displayed for you. After displaying, it will decrement. So A value will become 5. Now look at here. The pre-decrement. First it will decrement the value. So A value will be updated to 4. That will be displayed as an output. So if you execute this program, you will get the output as minus 4, 4, 6, 6, 4. Now let me show this program output. Okay. I will go to the command prompt and I will go to the desktop, cd desktop, and then I will write change directory Java programs because this program is saved in the folder called Java programs in the desktop. Now here I will write Java C operators.java. If there are any errors, it will display the errors. As this program does not have any errors, it has successfully generated the class file. Now you need to run. What is the command? Java operators. Look at here. The unary minus is minus 4. The post increment is 4. The pre-decrement is 6. The post decrement on A is 6. And pre-decrement is 4. See, whatever we have guessed, minus 4, 4, 6, 6, 4 has displayed. I hope you have understood the unary operators such as a unary minus and then post decrement, pre-decrement, post increment and pre-increment. I hope it is clear for you.
Now let me discuss about assignment operator. Without explicitly discussing about the assignment operator, we have used the assignment operator several times. The assignment operator, we will write it as equal. In mathematics, this is equal to compare the two things. But in programming language, this is an assignment and this will be comparison. So if you write simply A is equal to B, the meaning is that the value which is there in the variable B will be assigned to the variable A. If you simply write A is equal to B, here you are comparing. So the value which is there in the variable A, you are comparing with the value which is there in the variable B. If they are equal, then it will produce the output as true, else it will produce the output as false. But in this case, whatever the value which is there in the variable B will be assigned to the variable A. Similarly, we are writing A is equal to 6. The meaning is that the value 6 will be assigned to the variable A. Even the assignment operator, we can call it as a shorthand operator also. If I write A plus is equal to B, then meaning is that it is equal to A is equal to A plus B. Okay, suppose let's take that A value is 6, B value is 2. Then if you perform A plus is equal to B, which is A is equal to A plus B, A will get the value as 8. Previously A value is 6, now it will be updated to 8. I hope you are able to understand. Similarly, if I write A minus is equal to B, then it is nothing but A is equal to A minus B. Similarly, if I write A into is equal to B plus C, then how it will happen is that A is equal to, first it will perform the B plus C. Okay, for that one it will be perform the multiplication. So A into is equal to B plus C, if you write, first B plus C will be performed because the braces will have the highest priority as compared to the multiplication and addition. So first it will perform the B plus C. For that one it will perform the multiplication with the A value and the final result will be assigned to the variable A. So this is about assignment operator. Now let me discuss the assignment operator with a simple Java program. Let me take class sum operators. the class name I am taking it as operators, okay, where O should be capital. Then I will write public, okay, due to space issue I'm starting from here. Public static void main, okay, already I have discussed the meaning of each keyword. Public is the access specifier, static says that you don't need to create the object for this class, and void is this function does not return anything, and main is the function, and string, the s should be capital, and args, I can write args or anything. The name of this one can be anything, which is it should be an array, string array. Then let's take that I'm taking byte some x is equal to 4. Now the meaning is that you are assigning the constant 4 to the variable x, which is the data type is byte. So it will allocate 1 byte of memory, which is nothing but 8 bits. Okay. Now if you write system dot out dot println, okay, if you write simply x, then it will produce the output as 4 for you. Okay. Now similarly, let's take that you are taking byte a is equal to some 6. Then you have performed a plus is equal to x. Then it is nothing but a is equal to a plus x. And if you are printing the a value, system dot out dot println, okay, the a value is okay, see, you no need to perform this one, automatically it will be evaluated, like this is nothing but a is equal to a plus x. So x value is how much? 4. A value is how much? 6. So 6 plus 4 will be 10. That value will be assigned to the variable a. So the a value is, you can write plus a. Okay. Then in this case it will give you the output as 4. Here it will give the output as 10. Now let me close the void main function and the class. So if I execute this program, I will get the output as 4 and 10. Okay, let me show this program how to execute and what will be the output. Now right click on the operators and press edit with notepad++. Now operators.java program is opened in the notepad++. Now what I need to do, I need to discuss about the assignment operator. So I will write class operators and then I will write public static void main string args, and then I will open the main function, and here I will write int a is equal to 10 first. Let me display the a value, system dot out dot println. Here I can write the a value is, okay, plus and a. Now what will be the output will be displayed? The output will be displayed as this a value is 10. Now I have closed the main function and I have closed the class. Let me save it and then open the IDE command prompt, then cd desktop, because the programs are saved in the desktop Java programs. First we need to go to the desktop, then Java programs, and then we need to compile the operators.java. So Java C operators.java. Let me execute Java operators. See, we got the a value is 10. So how it is working? Once you have written int a is equal to 10, the value which is there in the 10, which is right hand side constant, will be assigned to the variable a. So the integer constant 10 has been assigned to the variable a. Okay. Now let me add few more things. Let's take that I am declaring integer variable b. Then if I write b is equal to a, and then if I print the b value, then it will display the output as, let me write here, the b value is, it will display the output as 10. Why? What is the value which is there in the variable a? You are assigning to the variable b. What is the value is there in the variable a? Here it was assigned 10.
So that 10 will be assigned to the variable b. Just for your understanding, let me execute this program. Java C operators dot Java, and then I will write Java operators. See, we got the output as the b value is 10. Now let me add few more things. If I write a plus is equal to b, then if I am displaying the a value is, now you can guess what will be the output. See, you have written a plus is equal to b. This is nothing but a is equal to a plus b. So the value which is there in the variable a plus the value which is there in the variable b will be performed addition, and the result will be assigned to the variable a. So what is the value is there in the variable a? 10. What is the value is there in the variable b? 10. So 10 plus 10 is 20. That will be assigned to the variable a. So this program will give you output as the a value is 20. Let me save it. Okay, and as I have modified the program, let me compile the program and then execute the program. See, we got the output as the a value is 20. Okay, now let me add few more things. If I write here, if I write a into is equal to b, then it will be a is equal to a into b. So 10 into 10 will be 100. That will be assigned to the variable a. So this program should display the output as 100. Okay, look at here, the a value is 100, it should display. Let me compile the program again, Java C operators.java. Then let me run it, Java operators. See, we got the output as the a value is 100. Now let me modify one more thing. I will write a plus is equal to, let me write here, c is equal to some 5, and then I will write b into c. Then what will happen? It will be like a is equal to a plus and then b into c. So according to the BODMAS rule, the braces will be given highest priority. So first it will perform 10 into 5. Okay, because the value which is there in the variable b into the value which is there in the variable c, which is 10 into 5 will be 50. That will be added to the variable a, which is 10. So 50 plus 10 is 60. That value will be assigned to the variable a. So you will get the output as the a value is 60. Let me save the program and then compile it, and then let me run the program. See, we got the output as the a value is 60. And we can do one more thing also. Here I will write a into is equal to b plus c. Now look at here, what will be the output? This is a is equal to a into b plus c braces. Okay, so as the braces will have the highest priority, first b plus c will be performed, which will be 15. That will be multiplied with value which is there in the variable a, which is 10. So 15 into 10 will be 150. That will be assigned to the variable a. So you are trying to display the a value. So this program will give you the output as the a value is 150. Let me execute the program. So first I will compile it and then I will run it. See, we got the output as the a value is 150. I hope it is clear for you.
Now let me discuss about relational operators. The relational operators are used to compare the two values. Like we have equal, which is used to compare whether the two variables are equal or not, and you have the less than or equal. You will have the greater than equal, and not equal. So these are the 6 different relational operators Java supports. Now let me discuss with a simple example. Let's take that a value is equal to 6 and b value is equal to 5. If you write a is equal to b, 6 is equal to 5. No, 6 is not equal to 5. So in this case, you will get the output as false. If the condition is true, meaning is that you are comparing. If the comparison is correct, then it will produce the output as true, else it will give the output as false. Similarly, if you are comparing A less than B, look at it. 6 is less than 5, false. So it will give the output as false. Similarly, if you write A less than or equal to B, 6 is less than or equal to 5. No. So again it will give the output as false for you. If you are comparing A greater than B, 6 is greater than 5. Yes, it is true. So in this case it will give the output as true. If you are writing A greater than or equal to B, is it clear? 6 is greater than or equal to 5, meaning is that 6 is greater than 5 equal to 5. Any one, 6 is greater than 5. So this is true. So it will give the output as true. Are you able to understand? Less than or equal. That's why we are saying or less than or equal. Any one. It can be less than or equal. Similarly here, greater than or equal. 6 is greater than 5. So it will be true. A not equal to B. Is it clear? So then you are writing 6 not equal to 5. Yes, 6 is not equal to 5 only. So in this case, it will give the output as true. Now let me discuss this relational operators with a simple Java program. Let me write a simple program. Let me take a class operators. Okay, you can use any name. Okay, but however, the name of the file and the class name should be same. So here the O I am keeping it as capital. Then public, okay, static void main, okay, and then you will have strings where S should be capital and args, okay, or you can use any name, okay. Then I will write byte A is equal to 6 comma B is equal to 5. Then A and B are the two variables of a data type called byte, and they will be occupying 1 byte of memory, and you are assigning the value 6 and 5 respectively to the A and B. So A will have the value 6 and B will have the value 5. Then if you write system dot out dot println, okay, A is equal to B. Similarly, if you write system dot out dot println, okay, if you write A less than B, similarly system dot out dot println A less than equal to B, system dot out dot println A greater than B, system dot out dot println A greater than or equal to B. Similarly, if you write system dot out dot println A not equal to B. Okay, let me close the main function and the class. Now look at here, the same one we have already discussed. A value is 6 and B value is 5. 6 is equal to 5. No. So in this case, it will give the output as false for you. Okay, A less than B. 6 is less than 5. No, false. It will give the output as false for you. 6 is less than or equal to 5. No. So it will give the output as false. 6 is greater than 5. Yes, correct. So it will give the output as true. A greater than or equal to B. 6 is greater than 5. So it will give the output as true. A not equal to B. 6 not equal to 5. Yes, it is true. So you will get the output as false, 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 true, true, true. I hope you have understood. Now let me execute this program and show the output for you.
Now let me modify the program and discuss with you the relational operators. We have several relational operators such as equal, okay, less than or equal to, all these things we will discuss. So I have created two variables called A and B whose data type is byte. So it occupies 1 byte of memory for the variable A and variable B, and you have assigned the value 4 and 6. So A will consist of value 4 and B will consist of value 6. Now we will use the relational operator. So I will write system.out.println the A is equal to B. I will write A equal to B is, and then I will use plus, and here I will write A equal to B or not. Okay, so it is useful for you to compare the value which is there in the variable a and variable b is equal or not. Similarly, I will perform the other relational operators such as less than. So here I will write a less than b. I will come check whether a is less than b or not. Similarly, I will check a less than or equal to b is or not. I will write simple b, small b. Okay, a less than or equal to. Similarly, I will check whether a is greater than b or not. And then I will verify whether a is greater than or equal to b or not. Then finally I will verify whether a not equal to b or not. A not equal to b or not. Now we will discuss what will be the output. A value is 4. Is 4 is equal to 6? No. So this will produce the output as false for you. Look at here, a less than b. Whether 4 is less than 6? Yes, correct. So in this case, it will produce the output as true for you. Then look at the next one. A less than or equal to b. 4 is less than or equal to 6. Yes, 4 is less than 6. So it will produce the output as true for you. Then a greater than b. Is 4 is greater than 6? False. Now look at here. A greater than or equal to 6. No, it is false. 4 is less than 6. Is 4 not equal to 6? Look at here. 4 not equal to 6. Yes, it is true because 4 is not equal to 6. So you will get the output as false true, true false, false true. Look at here. Let me execute this program. Okay, I am in the Java programs folder only. So I will simply write Java C file name which is operators.java. I have compiled the program and then you need to write Java operators. See, remember one important point. Whenever you have modified the program, again you need to compile. Without compiling, if you execute whatever the previous program you have compiled, for that program, whatever the output is there, that will be displayed for you. Look at here. Still I am getting this one. Okay, let me execute Java C operator, then I will write Java operator. Still I am getting Unary minus all these things. Okay, let me close this command prompt. I will save this one. Okay, then I will open the command prompt and I will go to the desktop, CD desktop, and then I will go to the Java programs. So I will return a command called CD Java programs. Now again I will compile the program called operators.java. It has successfully compiled. So now I will write operators, Java operators. See, we got the output as a equal to b is false, a less than b true, a less than or equal to b is true, a greater than b is false, a greater than or equal to b is false, a not equal to b is true. So whatever we have guessed is correct. I hope you have understood the relational operators.
Now let me discuss about the logical operators. Java supports three logical operators such as logical AND, logical OR and logical NOT. Now let me discuss each one in detail. Java supports logical AND, which will be represented like this. This is the notation to use the logical AND. Similarly, it supports logical OR will be represented like this. And also it supports logical NOT will be represented like this. Now let me discuss logical AND with an example. When you can watch my videos, if you have mobile phone or laptop or desktop, any computing device you should have, meaning is a mobile phone or laptop or a TV or anything which should have an internet, and you have the mobile phone, laptop and desktop, and you should have the internet facility, then only you can watch my videos. So if anyone is failed, you does not have these devices or you does not have the internet, then you cannot watch my videos. So whenever you want to compare more than one condition and both the conditions should be true, then only you can watch my videos. Similarly, let's take that when I can record these videos, I should have interest and I should have the knowledge, because I cannot teach everything. Some people are asking me to teach M1 subject. I know the M1, but the knowing M1 and knowing the M1 in such a way to teach will be different. Is it clear? So I should have an interest to teach the subject, and also I should have a knowledge. Then only I can teach the videos and record it for you. Is it clear? So whenever you have a condition 1, logical AND, condition 2. So logical AND in Java we will represent like this. So the condition 1 should be true and condition 2 also should be true, then only you will get the true. Is it clear? So the truth table of AND is, let's take that you have A, B, A logical AND B. Let's take that this is true, okay, and this is true, then you will get the true. If it is true and false, you will get false. False and true will be false. False and false will be false. So I hope with this truth table you can understand. If both the things are true, condition 1 and condition 2, if both are true, then only you will get the true. Whereas the logical OR, if any one of the condition is true, meaning is that this is true, this will be true, this will be true. When both the conditions are false, then only logical OR will give the false. I told you, let's take that when you can write a program, you can have a laptop or you can have the desktop or you can have the mobile phone, then you can execute this Java program. So this is logical OR. You can have a laptop. If you have a laptop, you can install the Java and you can execute the Java programs. If you have a desktop, then also you can do. If you have the mobile phone, you can use the online Java compilers and execute the Java program. So any one, either you have a laptop or a desktop or a mobile phone, but as a logical AND, both should be true. The logical not means if A is true, logical not of A, true not is false. If I say I am a good boy, if I apply not to it, I am not a good boy. Is it clear? Similarly, if it is false, if the input is false, not of false will be true. Is it clear? Because the logical not is an unary operator, because it needs only one operand, but whereas logical and logical OR are the binary operators. You need two operands. I hope you have understood the logical AND, logical OR and logical NOT. Now let me discuss these logical operators with a simple Java program. I will take a class. Name of the class is operators. So the meaning is that the name of the program you are writing is operators.java. Then I will write public static, okay, void main, okay. I hope it is visible for you. Now let me write it properly. Void void main string, where S should be capital. You can write args or any array you can take it, okay. Then I will take byte, okay, A is equal to 4, B is equal to 6, C is equal to 5. So I have taken three variables as A, B, C of a data type called byte. So each variable will occupy 1 byte of memory and you are assigning the values 4, 6, 5 respectively for the variables A, B and C. Okay. Now I am writing if A greater than B, logical AND A greater than C. Now let's take that you have A is greater than B and also A is greater than C. Then what you can say? Among A, B, C, you can say that A is the largest number. So I will write, okay, system dot out dot println, okay, A is largest, or A is the biggest number. Anything you can write. Okay. Else if I will write. Okay. See, just to make you understand the logical AND operator. In detail about the else if and else statements, I will discuss in the conditional statement. So, if is the keyword. See, if this condition is true, then the statements which are there in the if block will be executed. If the condition is false, because any condition can have either true as an output or the false as an output. If it is false, then the control will come to the else if block, and whatever the condition you have written here, B is greater than C and B is greater than A, then what you can say, you can write system dot out dot println. I'm writing it in a shortcut as SOP, which is system dot out dot println. I'm writing B is the largest number. B is the largest number. Now look at here. If this condition is failed, meaning is that A is not greater than B and A is not greater than C, then control will come here. Suppose let's take that this condition is also failed. B is not greater than C and B is not greater than A. The meaning is that A is not largest number, B is not the largest number. Then which is the largest number? Else C is the largest number. I will write SOP system.out.println C is the largest number. Okay, now let me trace this program. Okay, I will close the else, I will close the main function, and I am closing the class. Okay, now look at here. What is the A value? A value is 4. So look at here, 4 is greater than 6. Is the 4 is greater than 6? The condition is failed. Once this condition is failed, you no need to evaluate this one, because if both the conditions are true, then only the entire condition will be true. If the first condition itself is false, if the second condition can be either true or false, logical AND will give you the false. So you no need to compare this one, and you can say that this condition is failed. If this condition is failed, the control will come here and it will verify this condition. Look at here, B is greater than C. What is the B value? 6. C value is 5. 6 is greater than 5. This condition is true. Logical AND. B is greater than A. What is the B value? 6. Okay. B value is 6. A value is 4. 6 is greater than 4. Again, this condition is true. True, logical, and true. Then entire condition will be true. So the statements which are there in the else if block will be executed, which is the B is the largest number. I hope you have understood the purpose of the logical operators. If you use this logical OR operator here, if any one of the condition is true, then the statements which are there in the if block will be executed. So I hope it is clear for you. Now let me execute this program and show the output for you.
Now I will declare 3 integer variables like A, and I will assign the value 5, B is equal to 4, and I will assign C is equal to 6. Then I will verify if A is greater than B, logical AND, A is greater than C. Okay, I want to print the output as A is the largest number. So to print the output, we need to use the system.out.println, and I will write here A is the largest number. I will close the else block. If the condition is false, I want to verify whether B is greater than A, logical AND, B is greater than C or not. If it is true, I can say that B is the largest number. So system.out.println, B is the largest number. Okay, else. Okay, means if A is not the largest number, B is not the largest number, I want to print the C is the largest number. So system dot out dot print ln, I can write C is the largest number. I will close the else block, I will close the main function, and then I will close the class operators. Now I will go to the command prompt, and then I will go to the desktop, Java programs, Then I will write Java C operators dot Java. There are no errors. Now let me run it. Java operators. See, we got the output as C is the largest number. Look at here. As you have assigned, A is equal to 5, B is equal to 4, C is equal to 6. Then we got the C is the largest number. In place of logical OR, if you use the in place of logical AND, if you use the logical OR, what will be the output? You can verify. Let me run this program. Okay, save it, and let me compile the program again, and let me run Java operators. You can verify we got the output as the A is the largest number. Why we got the A is the largest number? You can verify. Logical OR means if any one of the condition is true, then entire condition will be true. Look at here. A is greater than B. This is the first condition. A is greater than B. What is the A value? 5. B value 4. So this condition is true because 5 is greater than 4. If the first condition is true, it will not even evaluate the second condition, because if the first condition is true, true logical OR true will be true only. True logical OR false also true, because if any one of the condition is true, the entire condition will be true. As the first condition is true, you no need to evaluate the second condition, and you got the output as the A is the largest number. It will not go to the else if block, and it will not go to the else block. So this is the difference between logical OR and logical AND. Now let me discuss about the logical NOT. Okay, to do this one, let me delete this entire one. I can say A is equal to 5, B is equal to 4, and here I will write if not, okay, if not A is equal to B, okay, then I want to print A is not equal to B. So I will use system.out.println. I will write here A is not equal to B. Okay. Else I will say A is equal to B. So I will write system.out.println A is equal to B. Okay, let me close the else block, close the main function, close the class of. Look at here, A value is equal to 5, B value is equal to 4. Now you are first comparing A is equal to B. A is equal to B. Look at what is the A value? 5. What is the B value? 4. 5 is equal to 4. This is false. To the false, you have given the not. So not false is equal to true. So if true, if the condition is true, you will execute the statements which are there in the if block. If the condition is false, then you will go and execute the statements which are there in the else block. Let me save the program. Okay, and here I will write CLS Java C, okay, operators dot Java. Then I will write Java operators. Look at here, we got the output as A is not equal to B.
Now let me discuss about the ternary operators. The ternary operators will be like if and else only. Like in ternary operator, let me write the generalized syntax. You will have a condition or some expression, then you will have the question mark, you will have the statement 1, then you will have the statement 2. Is it clear? So this is your ternary operator. Okay. Now the condition can be true or false. If the condition is true, the statement 1 will be executed. If the condition is false, the statement 2 will be executed. It is like an if and else. If you have a condition, okay, if the condition is true, you will execute the statement 1. If the condition is false, you will execute the statement 2. That's all. Simple. It is like a if and else. You have a condition. If the condition is true, statement 1 will be executed. If the condition is false, statement 2 will be executed. Now let me discuss about the ternary operator with a simple Java program. Class operators. Okay. The name of the class is operators where O is capital. And I am writing public where P should be small, public static void main, okay, then string aux where S should be capital, string, you can write aux or an A, anything, okay, you can use any name here. Then I am writing byte some x is equal to 4, okay, and y is equal to some 6, and I am writing byte a is equal to x less than y. I am writing the ternary operator, okay, then x else I am assigning y. Then if I print the value which is there in the variable a, now let me write it, system dot where s should be capital, out dot print ln, and if I write the value of a is, if I write plus, okay, I hope it is visible for you, or let me write simply the a value, okay. If I write concatenation and if I write a, then what will be the output will be displayed. Look at here. What is the x value? X value is 4, y value is 6. Now you have a condition x less than y. This is the condition. Okay, and then you have a statement x and statement y. Now look at here. What is the x value? 4. What is the y value? 6. So is 4 is less than 6? Yes, this condition is true. If this condition is true, this statement will be evaluated. If this condition is failed, this one will be evaluated. So meaning is that a is equal to x. If this condition is true, a will get the value which is there in the variable x. If the condition is false, then a will get the value which is there in the variable y. Now as this condition is true, the value which is there in the variable x, which is 4, will be assigned to the variable a. So meaning is that you are getting a is equal to 4. If you display the a value, you will get the output as 4. I hope you have understood about the working process of ternary operator. Now for better understanding, I will execute this program and show the output for you.
Now let me right click on the operators and press the edit with Notepad++. Now operators.java program has been opened in Notepad++. Now I will write class operators and then I will write public static void main string aux, and let me open the main, and what I will do is that I will declare some three variables, int a is equal to 5, b is equal to 6, and then I will write x. Now x is equal to a equal to b question mark a, then b ends with semicolon, system dot out dot print ln. I want to print the value of x. The x value is, then I will write plus and then x. Now let me close the main function and then class. Now what is the statement? I have a condition a is equal to b. If the condition is true, I want to assign the value which is there in the variable a to the variable x. If the condition is false, I want to assign the value which is there in the variable b to the variable x. Now look at the condition. 5 is equal to 6 because the a value is 5, the b value is 6. Is 5 is equal to 6? The condition is false. As the condition is false, the value which is there in the variable b, which is 6, will be assigned to the value variable x. So that variable you are displaying as an output. So you will get the output as the x value is 6. Let me save this program. Open the command prompt, cd desktop, cd java programs, then java c operators dot java. As there are no errors, we can run this one, Java operators. So we got the output as the x value is 6. Now let me modify the program little bit. I will take int a is equal to 5. Okay, I need to give the space. Int is the data type, a is the variable name, and equal to is an assignment operator, and 5 is an integer constant. Now I want to write system.out.println. If the given number is even number, I want to display as even number, else I want to display it as an odd number. So what I need to do here, I need to verify a condition. How we can verify whether it is an even number or odd number? I need to divide, means perform the modulus operation with 2. If the remainder is equal to 0, I can say even number. Okay, else I can say odd number. Let me close the println and ends with a semicolon. Look at here, a modulus 2. What is the a value? 5. 5 modulus 2. What will be the remainder? 1. Is 1 is equal to 0? The condition is failed. As the condition is failed, this program will give you the output as odd number. Let me save the program and open the command prompt. Let me press cls java c operators.java Java operators. See, we got the output as odd number. So like this, you can use the ternary operator. I hope it is clear for you.
Now we will discuss about bitwise operators in Java. Java supports various bitwise operators such as bitwise AND, bitwise OR, bitwise exclusive OR, bitwise complement, okay, and then shift operators such as left shift, right shift, unsigned right shift. All these things we will discuss in detail for you. Now let me discuss about all these operators. Like you have bitwise AND. Bitwise AND will be represented like this. Then we have the bitwise OR. Bitwise OR will be represented like this. Then we will have the bitwise exclusive OR. Exclusive OR will be represented like this. And then you have the and or complement we will represent like this. Okay, this is the symbol to represent the complement. And then we have the shift operation such as signed left shift, or we can say left shift. Signed left shift, we will use the symbol like this. This is the left shift. You are shifting towards the left side. Okay, and then signed right shift. Signed right shift. This is the symbol to represent the signed right shift. Similarly, you will have unsigned right shift. Unsigned right shift. This is the symbol for unsigned right shift. So these are the 7 different bitwise operators the Java supports. Now we will discuss about the bitwise AND in detail. Now what is the purpose of the bitwise operators? They will perform on bit by bit, whereas the logical and logical OR perform on the entire value, but the bitwise operators will be performed on each bit. Suppose if I take a byte a is equal to 4 and then byte a is equal to 3. Now not a, let me take b. Okay, now you know that byte will occupy 1 byte of memory, meaning is that this value will be stored in the form of 8 bits. Okay, so if you do that one, how you can represent the 4 in the binary number? The 4 will be represented in the binary number as 100. How to do it? You take the 4, divide by 2. Okay, 2 2s are 4 and the remainder will be 0. 2 1s are 2 and the remainder is 0. This is your MSB bit and this is your LSB bit. So you have 1 0 0 and the sign bit will be 0 because it is a positive number, and the remaining 4 bits will be 4 zeros. So this is the way a positive 4 will be represented if you are assigned with a data type called byte. Similarly, 3 will be represented as 1 1. Okay, and as it is a positive number, the sign bit will be 0 and the remaining bits will be zeros. Okay, if you have done this one, now what you need to perform? Bitwise AND between these two numbers. Bitwise AND, if you perform, 0 and 1 will be 0. Look at here. If it is 0, 0, you will get 0. Okay, if it is 0, 1, you will get 0. If it is 1, 0, you will get 0. 1, 1, you will get 1. If both the inputs are 1, the bitwise AND will produce the output as 1. In all other cases, it will produce the output as 0. So, if it is 0, 1, you will get 0, 0, 0, 0, 0, 0, 0, 0. So, if you convert this 1 to a decimal number, it will give you an output as 0. So, if you perform bitwise AND between A and B, it will produce the output as 0. Is it clear? I hope you got the point. Let me discuss with another example. Instead of 4, I will take 5. Just, okay, if you take 5, then it will be 1, 0, 1. Okay, remaining things are same. In that case, what will be happening? 0 and 1 will be 0, 0 and 0, 0, 1 and 1, 1 and 1 will produce the output as 1. In the remaining cases, it will produce the output as 0. So, this is nothing but plus 4, okay. So, if you are performing bitwise AND between A and B, where A is having the value 4 and B is having the value 5, then it producing the output as 4. So, this is about the bitwise AND. Now, if I perform the bitwise OR between A and B, so bitwise OR is if both the inputs are 0, then only it will produce the output as 0. In the rest of the cases, it will produce output as 1. 0, 1, it will produce output 1. 1, 0, 1, 1, 1, 1. Is it clear? So, if both the inputs are 0, then only it will produce the output as 0. In the rest of the cases, it will produce the output as 1. So, with this explanation, now let me perform the bitwise OR. Okay, I will write like this: A bitwise OR B. Then look at here, 1 and 0 means 1 bitwise OR with 0 will be 1, 0, 1. In remaining cases, it will be zeros because they are 0, 0. So, you will get zeros only. So, this if you convert into a decimal number, how to convert it? This procedure is simple. It is 101. Okay, each one has its weight, 2 power 0, 2 power 1, 2 power 2. So, take the bit value and its weight, multiply with, and then perform the addition. So, this is 1 into 2 to the power 0. Anything power 0 is 1. So, this will produce the output as 1, and 0 multiply with anything will be 0, and 1 into 2 to the power 2 will be 4. So, 1 plus 0 plus 4 is 5. So, this will produce the output as plus 5. Why? Because this is your sign bit. The MSB bit always will represent the sign because they are the positive numbers. So, the sign bit will be 0. So, bitwise OR has produced the output as 5. Is it clear? So, this is about the bitwise AND and bitwise OR. Now, let me discuss about the exclusive OR. To discuss about the exclusive OR, let me erase this content. Exclusive OR in digital logic design, we will represent like this. So, X bitwise AND Y complement or X complement bitwise AND Y. So, this is the expansion for exclusive OR. Now, if you substitute the X value as 0 and Y value is 0, look at what will be the output. 0 and 0's complement will be 1, or X value is 0, 0's complement will be 1 and Y value is 0. So, 0 and 1, just now we have discussed 0 bitwise and 1 will be 0, or 1 bitwise and 0 will be 0. So, 0 bitwise or 0 will give you 0. So, if both the inputs are same, you can take the same example, 1 and 1 also. Okay, if you take 1 and 1 also, this will be, look at here, 1 bitwise and 1's complement will be 0. Then X value is 1, 1's complement will be 0, and then this is 1. Again you take it. 1 bitwise and 0 will be 0. 0 bitwise and 0 will be 0. 0 bitwise or 0 will be 0. So if both the inputs are same, when x is 0 and y is 0, similarly when x is 1 and y is 1, you are getting the output as 0. Okay, remember this one. Similarly, if you take different values, if x is 0 and y is 1, okay, substitute that one. X is 0, so 0 bitwise, and y is 1, 1's complement will be 0, okay. Then x complement, 0's complement is 1, bitwise and y value is 1, okay. 0 bitwise and 0 will be 0, bitwise r, 1 and 1, okay, will be 1, 0 bitwise r 1 will give you 1. So if the inputs are different, then it will produce the output as 1. So now let me draw the truth table of the bitwise exclusive or. Suppose let's take that you have A exclusive or B. If it is 0 0, okay, let me write it properly, 0 0 0 1 1 0 1 1. If it is 0 0, it will produce 0. If it is 0 1 1 1 0 1 1 1 0. So if both the inputs are same, it will produce the output as 0. In the rest of the cases, it will produce the output as 1. So with this explanation, now let me perform the exclusive OR between A and B. Okay. A exclusive OR B will be computed as 0 and 1. The inputs are different, then it will produce the output as 1. Both the inputs are same, 0. Both the inputs are same, 0. Both the inputs are same, 0, 0, 0, 0, 0. So, A exclusive OR B, where A value is 4 and B value is 5, you got the output as 1. I hope you got the point, exclusive OR, how it will work. If you have understood this truth table, then performing this one is very simple. Now we will discuss about the complement. Now let me discuss about complement. The bitwise complement will be represented like this. To make you understand the complement, first I need to discuss how we can store a positive numbers and negative numbers in the memory. Okay, we have three representations such as sign magnitude representation, 1's complement representation and 2's complement representation to represent the positive numbers and negative numbers in the memory. However, there is an issue with the sign magnitude and 1's complement representation. What is the issue is, for plus 0 and minus 0, they have two representations in sign magnitude and 1's complement representation. However, plus 0 and minus 0 is 0 only. If it is plus 5 and minus 5, they are different, but plus 0 and minus 0 is same. But for the same number, we have two representations. So that's why we does not use the sign magnitude and 1's complement representation to store the negative numbers in the memory. So we go for the 2's complement representation. So in 2's complementation, how can we represent the plus 4 and minus 4? I will discuss with you all. Plus 4, suppose if it is an 8-bit, you are assigned byte A is equal to 4. Let's take that. If it is 4, how it will be stored? Okay. Already I told you, 4 binary number will be 100. As you are assigning 8 bits, the sign bit will be 0 because it is a positive number. Remember one thing, if sign bit is 0, then it is a positive number. If sign bit is 1, it is a negative number. So remaining 4 bits you will assign. So this is the way in memory the plus 4 will be stored. Now how the minus 4 will be stored? The minus 4 will be stored in 2's complement form is, first you will represent the plus 4. How plus 4 is represented? Like this, 5 zeros, 1 000. For this number, you need to compute the 2's complement. How you can compute the 2's complement of any number is, first you need to compute the 1's complement and add 1 to the LSB. Okay, compute the 1's complement and then add 1 to it. Now you can ask me, sir, how can we compute the 1's complement? Yeah, it's a good question. 1's complement, how can you find it is, if the input is 0, 1's complement of 0 will be 1. 1's complement of 0 will be 1. 1's complement of 1 will be 0. So the point here I want to highlight is, if the input is 0, 0's complement will be 1, 1's complement will be 0. So it is just opposite. Good, not good. Bad, not bad, like that. Is it clear? Okay. So first we will compute the 1's complement of the given number. How can we compute the 1's complement? It is very simple. 0, 1, 0, 1, 1, 0. This is the 1's complement of the given number. How can we compute the 2's complement? Once you computed the 1's complement, add 1 to the LSB. I will add the 1 here. Is it clear? So now 1 plus 1, okay, the sum will be 0, carry will be 1. Okay, again 1 plus 1, the sum will be 0, carry will be 1. 1 plus 0, sum will be 1 and carry will be 0. 0 plus 1, 1, 0. 1, 1, 1, 1. Is it clear? So this is the 2's complement of the given number. Okay, so this is the way minus 4 will be represented. Okay, this is the minus 4 representation in the memory. I hope you have understood how to compute the 2's complement. So first, if you want to find the representation for minus 4, first you will represent plus 4. For plus 4 representation, you will compute the 2's complement. How you will compute? First you will compute the 1's complement and add 1 to the 1's complement to get the 2's complement. So this is the way. Now with this explanation, now let me discuss how can we perform the bitwise complement. Okay, is it clear? Bitwise complement we can say, or bitwise not, anything we can say. Okay, now let's take that byte A is equal to some 5. Someone has asked you to display system.out.println, okay, complement of A. Now what will be the output will display? Is it clear? Now we will compute that one. Okay, how we will compute? Let me discuss it with you. How the 5 will be represented? This is positive 5. Positive 5 how will be represented? In 8 bits, as it is a byte. 1 byte of memory will be allocated, which is 8 bits. So 5 is 101 and the sign bit will be 0 because it is a positive number, and then remaining 4 zeros. This is plus 5. Now complement meaning is that same. If the input is 0, complement of that 1 will give you output as 1. If the input is 1, complement of that 1 will give you output as 0. Is it clear? So if I do this 1 complement, this is 1 0 0 1 0. This is the complement of the given value. Now look at here. Okay, now what is the sign bit? This is a 1. The sign bit is 1. What it represents? It is a negative number. If it is a negative number, what is the value will be stored? It will be stored in 2's complement of the original number in the memory. So what the lot of students will do the mistake is that they will simply convert this number to the decimal number and says that complement of this one is this one. Okay, what is the number they will get it is, if they do it, this is 2 to the power 1. So this will be 2 plus 8 plus 16. Okay, this is 8, 16, 32, 64, 128. They will get 2 plus 8 plus 16 plus 32 plus 64 plus 128. So 128 plus 64 is 192. 192 plus 32 is 224. For 224, if you add 16, it will be 240. 240 plus 10 will be 250. They will simply say you got the output as 250. If someone's given such explanation, it is absolutely wrong. Why it is absolutely wrong is that as this is a sign bit is representing 1, it is a negative number, and you know that negative numbers in memory will be stored in 2's complement form. So if you want to get the original number, for 2's complement number, there is a property. Suppose if a given number is x, if you compute the 2's complement, you have computed the 2's complement of the x, you got the y. Okay. For this y, again you compute the 2's complement, you will get the x. Is it clear? I hope you have understood. For a given number, if you compute the 2's complement, you will get some result. For that result, again you compute the 2's complement, you will get the x. So if you want to get the original number, for this number you need to compute the 2's complement. How to do it? Let me discuss with you. Okay. For this number, the 2's complement will be, I will do it in a shortcut. Okay. 0 will be, keep it as 0. The first one will be, keep it as 1. For the remaining ones, you will compute the 1's complement. It will be 1, 0, 0, 0, 0, 0. So this is the 2's complement of this number. Okay. First, how many zeros are there? Keep as it is. The first one keep as it is. For the remaining numbers, you compute the complement. So 0's complement will be 1 and 5 ones are there, 5 zeros. So, but this is a negative number, okay, because the sign bit is 1, so it is a negative number. Now this number you convert into a decimal. This is 2, this is 4, so you got the minus 6 as an output. I hope you have understood how I got the minus 6. So this will produce the output as minus 6. I hope you have understood. Now let me discuss with another example. If I have taken a value is equal to minus 4. If it is minus 4, what is the complement of a? Okay, that also I will discuss with you. First, how minus 4 will be represented or how minus 4 will be stored. I told you earlier, first we need to store the plus 4. Plus 4, how it will be stored? 1, 0, 0. This is the binary representation of 4 and 8 bits as the sign is a positive 4. First we are representing the plus 4. So sign bit will be 0 and the remaining bits will be 4 zeros. Okay. Now for this number you will compute the 2's complement. The 2's complement of this number will be, okay, this one. If you have a doubt, you do the normal procedure. Compute the 1's complement and add 1 to the LSB. So minus 4 will be represented as 6 ones and 00. Okay, once you got the minus 4, for this one you need to compute the complement. Okay, because they have asked you to perform the complement of a. So in memory, minus 4 will be stored like this. For this one, if you compute the complement, look at here. This will be 1, 1, 0, 0, 0, 0, 0, 0. So you got 6 zeros, 2 ones. Okay, now look at here. This is sign bit is 0, so it is a positive number. So positive number will be directly represented in the memory. So 1, 1. If you convert into decimal number, you will get the 3. So this will produce the output as 3 for you. I hope you have understood the bitwise AND, bitwise OR, bitwise NOT, bitwise exclusive OR. Okay. Now we will discuss about the shift operations such as left shift, right shift, unsigned right shift. Signed left shift, or I can simply say left shift. The left shift will be represented like this. This is left hand side. So that's why the arrows will be like this. Okay. Suppose if you have a byte a is equal to 4, okay, and if someone asked you system.out.println, okay, println a left shift 2, then what is the meaning is that any left shift operation will be represented like this: a left shift b, meaning is that on a you need to perform left shift b times. If here it is 2, 2 times you need to perform the left shift. If here it is 3, 3 times. If it is 1, 1 time. So let me discuss with an example. A value is 4 here and B value is 2. So on the value 4, you need to perform the left shift 2 times. Okay. Now how it will be performed? Now let me discuss it with you. As it is a plus 4, how it will be represented? 1, 0, 0 and then 5 zeros. Okay. Now if you perform the left shift by 1, left shift means what? This side shifting. Okay. So look at here, the 8 bits. Again you should get the 8 bits after performing the left shift. Okay. So this 0, okay, let me write it here. Okay, you have a 0. Okay, these are 8, 4, 8. Yeah, this 0 will come here.
left shift by 1, then 0 1 0 0 0 0. This empty bit you will get it as 0. So this is about the left shift. So what is the value you got? We will keep it like that. Now again they asked you to see this 0, you will lose it, okay, because 8 bits are there. That one if you shift that you will lose it, okay. Now again you want to perform left shift by 1 bit, 4, and this 0 you will get here because the first bit will become second bit now. Then 0 0, okay, 3 zeros, 1 3 zeros, okay, and then you will have the 0, okay. So this is about the 4 if you perform 2 times left shift. So this value if you compute into a decimal number, this will be how much? 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. So 16. So if you display this one, you will get the output as 16. So this is about the signed left shift, or I can say simply say left shift, okay. So the procedure or the formula for computing directly is a into 2 to the power b, okay. A value is 4 and b value is 2, so 2 to the power 2 is 4, 4 into 4 is 16. It is very simple, okay. Now similarly, if I ask you to discuss about the signed right shift, you need to perform the right shift, okay. Now look at here, a value is 4, and if I say right shift by 2, okay, then you need to perform 2 times right shift, okay. Look at here, let me discuss with this one with a negative number for better understanding, okay. Now a right shift by 2 means 2 times you need to perform the right shift, okay. So first you need to represent the -4. How we will represent the -4? First we will represent the +4. +4 how we will represent? 1 0 0, and the remaining 5 zeros you will have, okay. This is -4. Now I will convert this into -4 by computing the 2's complement. How can I compute the 2's complement of this number? Keep the zeros as it is, first one as it is. For the remaining ones you compute the complement. So 5 zeros, 5 ones you got. Now this is -4 will be stored in the memory. Now for this one I need to perform the signed right shift, okay. This is right shift, signed right shift. Now how we will perform the signed right shift is, okay, you perform the right shift. Now look at here, 8 bits. After performing also you should get 8 bits. These are 4, this is 8, okay. This 0 you will get here, this 0 you will get here, this one you will come here, this one it will come here, this one will come here, this one will come here, this one will come here, okay. Are you able to understand? How many? 3 6 7, okay. Is it clear? Then you will have, okay, you will have a empty position here. As it is assigned, what is the sign bit is there, okay, that one you will keep as it is here. So this is about the signed right shift. Now look at here, what is the sign bit? It is a 1. So what is the meaning? It is a negative number. For a negative number, how we can compute it? Again we will compute the 2's complement. So negative number you will keep minus sign. Then for this one you will compute the 2's complement. For this number if you compute 2's complement, it will be 0 0. First one you will keep as it is, remaining you will keep zeros, okay. Are you able to understand? You are performing the right shift. So this 0 will come here, this 0 will, you will lose. Oh sorry, I really did a mistake here. That is what, okay. This is how many bits are there? 8 bits are there, 6 2 zeros. See, look at here, you need to keep 8 bits, 5 and 3's. This 0 you will lose if you perform right shift. Suppose let's take that L R H was sitting. If I perform right shift, this person will fall down. So this 0 you will lose. This 0 will come here, and 1 1 1, okay, and then 1 1, and here what you need to keep? What is the sign bit? As it is you will keep. So if you perform the
2's complement of this number, as it is a sign bit is a negative number. For this one, if you compute the 2's complement, you will get 0 here. The first one as it is, and the remaining bit you will compute the complement. So you will have 6 zeros. Okay, 6 zeros, 1 0. So this is minus 2. So this is about the signed right shift. So if you perform the right shift on minus 2, you will get the output as minus 2. If it is an unsigned right shift meaning is that, let me discuss with a simple example. Unsigned means the left out positions. Whenever we are performing right shift, we are losing some values, am I right? Suppose if it is a plus 4, how I will represent 1 0 0, okay, then 5 zeros I will keep. Then if I am performing 4 on unsigned right shift by 1 bit, then what will happen is that unsigned, so you will have again 8 bits. Okay, this is 3 8. So this 0 you will lose, and this 0 will come here, this 1 will come here, here 0 0 0 0. Here the empty position, you will not look at the sign, you will simply keep the 0. Okay, in this case it will be plus 2. Okay, if you perform unsigned right shift on 4, you will get the plus 2. The only difference between the signed right shift and unsigned right shift is, in a signed, whatever the sign bit is that bit you will fill, but whereas an unsigned, you will simply fill with zeros. Okay, I hope you have understood all the bitwise operators. I will discuss with a simple program for better understanding.
Now, let me right click on the operators and press the edit with Notepad++ option. Now, operators.java program has been successfully opened in the Notepad++ IDE. Now, I will write class operators, then public static void main string aux, and let me open the main function. I will take two variables, int a is equal to 5, b, or let me take int a is equal to 7, b is equal to 4. Now I will write system.out.println, okay, bitwise or is, okay, I will write plus a bitwise or b. I will do, let me copy this one and paste the, instead of bitwise or, I will perform the bitwise AND between A and B. So here I will write the bitwise AND. Similarly, I will perform the bitwise exclusive OR between A and B. So I will use the bitwise exclusive OR. Now let me perform the bitwise complement. So bitwise complement you can perform on the single variable. So complement A. Now let me perform the left shift right shift operation. So bitwise left shift on the A, and I want to perform left shift by 1 bit. So I will write A left shift by 1. Okay. Similarly, let me copy this one. I want to perform the right shift now. Okay. Signed right shift. I want to perform by 1 bit. Okay. Similarly, I want to perform unsigned right shift on variable A by 1 bit. Now let me close the main function and let me close the class. Now what I will do, I will compile this program. So I will open the command prompt and I will go to the desktop. So cd desktop, then cd java programs, and then I will compile the Java program. So Java C operators dot Java. See, we are getting some error. Illegal start. So, we need to perform the bitwise right shift. Okay, bitwise unsigned right shift. We have performed unsigned left shift. That is not allowed. Okay. Now I have saved the program. Let me enter CLS and compile the program again. Java C operators.java. As there are no errors, we can run the program. Java operators. The bitwise OR is 7, bitwise AND is 4, bitwise exclusive OR is 3, complement is -8, left shift we got 14, unsigned right shift we got 3, unsigned right shift we got 3 because this is a positive number, so there was no difference. I hope it is clear for you.
Now let me discuss about instance of operator in Java. The instance of operator is used for checking if a reference variable is containing a given type of object reference or not. Is it clear? Suppose let's take that. For a class you have created an object. For that class, is this is an instance of an object or not? Means for the given class, whatever the object you have created, is this object is for this class or not? You want to verify. Then you can use the instance. Similarly, let's take that. You have created a string. Okay, string some name is equal to you have given Parnika. Now is name is an object for the string or not? If you want to verify, you can do it. Name instance of string, then it will give you the output as true. So instance operator is used for checking if a reference variable means the object or anything is containing a given type of object reference or not. Now let me discuss with a simple example. I am creating a class called, okay, let's take that first. Okay, first is my class, and then you know that I will write public static, okay, void main, then you will have a string where s should be capital, string args, okay, this one, or you can write args or anything you can write here. Then I want to create an object for this class. How can you create an object for this class is, first you need to write the class name. Okay, you need to write the class name, object name. Now let me write it as ob1. So for this class I am creating an object called ob1. So you need to write a class name space object name is equal to new class name, okay, braces. So this is the way you can create an object for the class. So let me discuss again. This is class name, object name, new class name. Is it clear? So you have successfully created an object for the class. Now you want to verify, is this an object for the class called first or not? Okay, how can you do is that you can write system dot out dot print ln, okay, you can write, okay, ob1 object 1 instance where I should be small and of instance of, it is a single one, okay, instance of class called first. Okay, if this object 1 ob1 is belongs to the class first, then it will produce the output as true for you, else it will produce the output as false. Okay, is it clear? Let me close the main function and the class first. So this is the way you can use the instance of operator. Now let me discuss this one with a proper way of executing this program and see whether we are getting the output as true or not.
Now let me right click on the operators and let me select the edit with notepad++. Then the operators.java program has been opened in notepad++. Now let me write the program. Class operators, then public static void main string args, and then I will open the main function. Now I will create an object for the operators class. How to create an object? I can write operators object name. Let me write as OP is equal to new operators. So class name object name is equal to new class name. Okay. Now I want to verify, is it an instance of OP is an instance of operators class or not. So how can I do? System dot out dot println. I can write OP instance of operators. Let me ends with a semicolon. I will close the main function and I will close the class. Let me save it and let me open the command prompt, and here I will write the cd desktop because I need to go to the Java program. So cd Java programs, then I will compile the program Java C operators dot Java. It is successfully compiled, so it will give a class file called operators.class. Now you need to run it Java operators. Now we got the output as true. So the OP is an instance of operators. Now let me show it another one for you. I will write OP1. OP1 instance of operators. I will save it. Okay. Let me run the program again. See, you got an error OP1. Let me create. OP1 is an integer variable. So int OP1. Now I will save the program and then let me compile it again. See, you got OP1 instance of operators unexpected type. So you are getting an error here. Is it clear? If I write OP is an instance of operators because it is an object for the operators class. So that's why you are getting the output as true. If you have a doubt, let me clear the screen and compile the program again, and let me run the program. See, we got the output as true. I hope it is clear for you. If you still have any doubts related to the operators, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.